There are several images captured by the Webb telescope, and they concern various bodies, planets, asteroids, and clusters of galaxies. But there is a very particular one. The galaxy that you see has a tiny red blob in this image and has been dubbed GLASS Z13. It is thought to be the most distant galaxy ever known, and it was spotted by the James Webb Space Telescope. It lies at approximately redshift 13. That's where its name comes from. This discovery was presented in July of 2022, but now, only a few days later, some papers came out, claiming that even more unusual galaxies, and even more extreme, were found among the data provided by the amazing James Webb Space Telescope. This new chat is currently going on Twitter, despite the studies still being preliminary and not peer-reviewed. Of course, in the next months, we will have a more precise idea. But why don't we talk about what the papers say? You'll see that if they got it right, they suggest the existence of galaxies that sort of break modern theories. Keep watching the video to get to know about the oldest galaxies in the universe and more. James Webb found galaxies that could challenge modern theories. As we've already said, the new discovery we're going to discuss is still absolutely preliminary, but could forever change the way we see the universe, especially the way we see the early universe, when the first objects such as stars and galaxies were forming. What this data basically suggests is that we might have underestimated the age by which galaxies formed. But if this turns out to be true, we might also have underestimated the age of the first forming stars. This discovery is breaking all the rules, and if the results are confirmed, we're in trouble. For example, they contradict a lot of the early predictions and a lot of modern understanding when it comes to the evolution of the universe. But why? Let's start from the basics, from what our theories predict about the early phases of the universe. Let's only see the key points. The Big Bang happens, and the universe appears everywhere as a very hot, very dense single point in space. The afterglow of light and radiation left over from the Big Bang is contained in the so-called cosmic microwave background, which we can still observe and study in great detail. Then, in a very small fraction of a second, the universe undergoes an incredible growth spurt. This is known as inflation. During the inflation phase, the universe doubled in size at least 90 times. As the universe expanded, it got cooler and less dense. This allowed matter to form. Light elements are created within the first 3 minutes. In fact, as the universe expanded, protons and neutrons collided to make deuterium, which is an isotope of hydrogen. Much of this deuterium is combined to make helium. Up to this point, however, the universe was still too hot to shine, because atoms at high temperatures were colliding, forming a plasma of protons, neutrons, and electrons that scattered light as a fog. Then, at an estimated age of about 380,000 years after the Big Bang, the universe, still expanding, and matter cooled enough for electrons to combine with nuclei to form neutral atoms. This is the so-called recombination phase, and at this point, the fog finally went away, and the universe became transparent. Photons were finally free to travel, but this era was soon followed by a period of darkness. Dark Ages. After recombination, about 400 million years after the Big Bang, the universe went dark again. This period is called reionization, and we don't know exactly what happened and which objects were responsible for the reionization, but during this period, clumps of gas collapsed enough to form the very first stars and galaxies. After the reionization, stars and galaxies were still forming. This is something that we know, and Hubble Space Telescope has proved it right. For example, this image taken by the HST shows a cluster of galaxies residing 10 billion light-years away. This is basically what we need to understand the new discoveries. Let's see how they contradict this scenario, which seems actually strong and based on solid ground. From the Big Bang Theory, we know that stars form first, and then galaxies. We also know that the recombination epoch came first, and then it was time for the reionization. But the big problem with this scenario is that we have a little bit of uncertainty between the dates these events happened, and we don't exactly know for sure when the first stars formed, stars started forming galaxies, also why they started doing so, and what led them to form more complex structures. If you're still here, it means you're really enjoying this video. Why don't you subscribe now and press the bell notification? What scientists are trying to do in order to answer some of these questions is to look for the so-called population 3 stars. Such stars are hypothetical stars because scientists didn't seem to have found any of them until now. Population 3 stars are basically the first stars to have formed, and therefore if they exist, they should be composed entirely of primordial gas, hydrogen, helium, and very small amounts of lithium and beryllium. The gas from which population 3 stars formed had not been recycled, incorporated into and then expelled from previous generations of stars, but was pristine material left over from the Big Bang. The only problem is that population 3 stars are entirely hypothetical at present. Despite intense searches, no population 3 star has ever been observed. But maybe the James Webb Space Telescope could help us find one. In fact, JWST is supposed to be really good at finding population 3 stars because of its ability to see the infrared light, and infrared light in this case is very important. Because at these distances, all of the original ultraviolet light from all of these very powerful stars had actually been ratcheted into very specific infrared frequencies. We were able to detect some of these frequencies with the Hubble Space Telescope, but its limit was set at approximately 400 million years after the beginning of the universe. Instead, James Webb is able to see much, much further. In terms of redshift, Hubble was able to reach Z equals 11, while James Webb reaches Z equals 13. For example, for GLASS Z13, the redshift of 13 gives us the age of about 330 million years. What the new papers claim to have found is a bunch of objects in the iconic cluster SMACS 0723-73. This image came out in July. It was one of the first 5 Webb images to come out. As we've said in a previous video, this cluster is also gravitationally lensed. This can be seen from the unusual warping of the galaxies. As with every other lens, the gravitational lens allows scientists to see much farther than would be otherwise possible. What the teams did was analyze the raw data from all the observations of this cluster in order to find some potential new record holder objects. The first team basically found 55 highly redshifted galaxies, and 44 of them seemed to be entirely new. But more importantly, 6 of them were at the redshift of over 12, and one of them had a redshift of 16.7. This number is huge. If confirmed, it would make it the new record holder. This would be a very young galaxy, only 230 million years old. This is, of course, in contradiction with the scenario we have discussed before. Let's understand why. If we are able to detect this light coming from such a distant galaxy, this would imply that some of the neutral hydrogen present at that time absorbed the ultraviolet light coming from the early stars, but would instead allow other light to pass through. This means that such ancient galaxies already existed during the Dark Ages. This is something completely unexpected, and in a certain sense, scientists hope the results are wrong. For example, astrophysicists wouldn't know how to explain the presence of such a high mass content in the early universe. The second paper instead identified 88 candidates, and they say that at least one of their candidates is at the redshift of 20. This is a huge distance and tells us that this galaxy formed when the universe was only 180 million years old. So, are these the final results? Of course not, but they are very preliminary, and we just need to wait for more studies to be done and peer-reviewed. But if this turns out to be true, we would be in serious trouble. In that case, we would need a new scenario, and this scenario has to be able to match the observations. When it comes to science, one of the most important requirements for theory is to always match the observations. When this doesn't happen, it probably means it's time to go for a better theory. Or maybe our instruments and ways of measurement need to be improved, who knows. Anyway, I'm pretty sure that in the next months we will hear about new discoveries. The James Webb Space Telescope era has just started, and the revolution is already coming, we had no doubt. However, to confirm that the galaxy is as old as its redshift suggests it is, astronomers will use spectroscopy to analyze the magnitude of light across a range of wavelengths for all the galaxies Webb's near-infrared spectrograph instrument has found so far. This device uses tiny 0.1 mm long, 0.2 mm wide adjustable mirrors that only let in light from target galaxies, tuning out background radiation so that astronomers can break down a galaxy's star by color. This will reveal both the age of the galaxy's light, but also their chemical composition, size, and temperatures. This again is important to test our theory, because astronomers also think the first stars were composed mainly of lighter elements, such as hydrogen and helium. Also, given the stunning rate of Webb's discoveries, along with its ability to look as far back as 100 million years after the Big Bang, it's highly unlikely that this is the farthest galaxy we will see. The telescope will probably break its own records a lot in the coming months. Are you ready? That's all for this video. Do you think James Webb will revolutionize our understanding of the universe? Let us know in the comments below. And if you enjoyed the video, don't forget to share it. And I'll see you next time on the channel.